I would like to remind you that for more Microsoft webcasts, you can go to microsoft.com/webcasts. Thanks again for joining us for today's presentation, Data Programmability and SQL Server 2008. Now it is my pleasure to introduce today's presenter, David Skepa. David, you now have the floor.
Thank you very much, Colleen. Hello, everyone. Thank you for coming to the webcast. My name is David Skepa. I'm a program manager on the Microsoft ADO.NET team. Some people may recognize my name. I've written a couple books for Microsoft Press on ADO.NET and ADO in the past. And I'm going to be writing the Microsoft Press book on the ADO.NET Entity Framework as well. Today we're going to cover a lot about Link and a lot about our data access story for both Visual Studio 2008 and SQL Server 2008. We're going to talk about what's so exciting about Link. We're going to look at various ways in which you can use Link to work with your data. We'll talk about the main differences between Link to SQL and Link to entities. We'll then go into more depth and take a closer look at the ADO.NET Entity Framework. We're also going to talk about Project Astoria. And then we're going to spend a little time looking at the new SQL Server 2008 data types. In terms of prerequisites for this session, we expect that people attending the session have a basic understanding of .NET programming, whether that be in either C# or Visual Basic. I'm going to try to go back and forth between samples in both languages. And we expect that attendees have a basic understanding of querying a SQL Server database. This is a level 200 session, so we're going to have a high-level overview about a number of technologies. We're not going to go into a great deal of depth about any particular technology. The agenda for this session will introduce Link, Link and data access, talk about the ADO.NET Entity Framework, talk a little bit about Project Astoria and the new SQL Server 2008 data types, and then go over a session summary. So with that said, let's take a closer look at Link. So first off, what is Link? A lot of buzz on this term and this technology among developers, but there's still a lot of developers who've yet to be exposed to it. Link stands for Language Integrated Query. Easy for me to say. Link is a technology that allows developers to query their data structure using a very familiar SQL-like syntax from within their application's code. There are a lot of scenarios where you have objects and data in memory, and you want to perform some task with that data in memory, access certain pieces of data within your data structures. And there are a lot of scenarios where if you imagine that data were in a SQL Server table or a database table in some other data store, that there are simple ways for you to imagine retrieving the data you're interested in using SQL, but trying to translate that into Visual Basic or C# code, it can often be quite a challenge. Link is a technology that greatly simplifies that. Link is available to both C# and Visual Basic developers in Visual Studio 2008. It's an extension of many of the classes that were in version 2.0 of the .NET Framework. So let's take a quick look at an example using Link. Here's an array of integers in C#. There's no order to this array whatsoever. If we wanted to look for just the odd numbers in the array and return them in descending order, if you wanted to write this code in C# or Visual Basic traditionally, you would need to loop through the items, determine which items are odd, store them in some structure, maybe an array list, maybe a sorted list of some sort, And then after you've looked through the available items, you'd want to return them in the appropriately sorted order. Now if you break that down into a couple steps, the first part of looking for items in the array that are odd is very straightforward. Most people could write that code in their sleep. But oftentimes when you're building an application, the logic becomes progressively more complex. If all you wanted was to store that data and return it in the order in which you saw the items, you might use a stack. But if later you determine, hey, I need to sort this in a particular order, suddenly you need to make massive changes to your code and how you're processing that query. Using a technology like LINQ, all you need to do is change the structure of the query. Once you've designed the query, you use a for each loop, and when you execute that for each loop, that's the point where you're actually executing the query and processing the results. Now you may notice that there's no data type listed for this query. It just says var. Var is a new keyword in C# in Visual Studio 2008. And what that literally means is it is strongly typed, but we want the compiler to infer the data type. In this case, this is an IEnumerable of integer. Because of the structure of the query, the compiler can tell this is going to return a series of integers. Because the compiler is able to figure this out, you're still able to work with this odd numbers variable as if it were clearly defined in your code. You're not losing anything by saying var odd numbers. If we were working in Visual Basic, rather than var, we would simply use dim. So let's take a closer look at a demonstration of using LINQ to query an array. And I'm going to do this in C#. And here's my code. I have my array defined. And first off, I just want to print the odd numbers. Through the miracle of code snippets, I saved myself a little bit of typing. So we see here, from I in my array, we use a where clause, just like a standard SQL query, where I mod 2 is equal to 1, select I. And then we loop through the available integers and print them out. Very standard, very simple. Now if we want to do the same query in descending order, I could take this original query and paste it and add an order by clause. But one really nice thing about LINQ queries is that they're composable. And by that I mean that I can define a new query and reference the old query. So I don't have to define again that I'm looking for numbers where the value mod 2 is equal to 1. I can reference the original query. And again, at this point when I've created this query for the descending order, I've composed the two queries together. Neither one of them has been executed yet. The query is not executed until I perform the for each and until I access the enumerator for that query. So this is very handy. It allows you to break queries into smaller and smaller tasks. And once you have a query that returns the data you want, you're able to continue to leverage that. Now these are very basic queries, and LINQ does allow you to do grouping, a lot of very advanced filtering, and some other features. We can get a sum of these numbers by actually referencing the query and calling the sum function. LINQ also allows you to do grouping and aggregate functions inside the query itself. But many times all you need to do is perform a sum over the query. And that's what we've done here. And when we call the sum method, the query is executed and the sum of the values is returned. So now let's run the code, make sure it actually worked. What's the point of a demo if you only show the code that you're working on and don't run it? And it would help if I set the right startup project. So here we printed the odd numbers. You can see that they're not in any sort of order. And now we've printed them in descending order. You can see that they're in descending order. And lastly, we printed the sum of the odd numbers. So that you can see that LINQ itself is a very handy technology. We have enabled the various collection classes from .NET 2.0 so that you can work with them with LINQ. The array class, which we saw before, an array of integers, we could work with that. Any class that implements IEnumerable, hash table, list of t, etc., you can use any of them with LINQ in Visual Studio 2008. We've also extended the dataset class so that you can use LINQ-based queries using strongly typed datasets or untyped datasets. We're going to look at an example of that shortly. Our XML technologies are LINQ-enabled. We support LINQ queries against XML documents. And in terms of actual interaction with the database directly through LINQ, we have two data access technologies that are LINQ-enabled. One is LINQ to SQL, and the other is LINQ to entities. We're going to be talking about those a little later on in the session. So now let's take a closer look at LINQ to data access. In terms of technologies that developers are already familiar with, the easiest example of using LINQ to query a complex object model is to use LINQ with the strongly typed dataset class. So if we have a strongly typed dataset that is geared to work with the standard sample Northwind database, we can pull data into that dataset and then use LINQ to query the dataset. So here I have a Visual Basic query that uses LINQ to look at the orders in the dataset and applies a filter. I just want to look for the orders for a particular customer and select the entire order row in each case, iterate over those rows, and print out information. With that said, let's take a closer look at using LINQ to query a dataset. And we're going to take a look at this using Visual Basic. This time I'll remember to set the startup project. Okay, I've already defined my strongly typed dataset in my Visual Basic project. I have data tables for products, customers, employees, orders, and order details. And after creating the dataset object, I instantiate various table adapters and call the fill method on each table adapter to populate the data in my dataset. Now I could execute a query like the one we saw in the code just a moment ago, where I'm returning entire data rows of data. Now because the data row on the strongly typed dataset is also strongly typed, I'm able to use IntelliSense to look at the contents of those data rows, order ID and order date. And that's nice, but that's very simplistic. I want to show more of the power of LINQ here. I want to show a query that I couldn't execute using .NET 2.0. With .NET 2.0, I could use various methods on the dataset class. For example, the select method on a data table. And I could pass in criteria similar to the criteria we just saw. We were looking at a particular field in that table and performing a simple comparison there, and then looking at data just from that data table. We get countless requests for, could you add join functionality? Could you allow me to execute a query against the data set and return a projection of data, just certain fields? With LINK, those queries are very simple. Here what I've done is I'm looking for orders within the data set, but now I want to apply filters based on related tables. I want to see the orders for customers from Argentina that were placed by a particular employee. And now, rather than just look at those data rows, I want a more complex structure. I want to see just a couple fields from the orders table, order ID and order date. I also want to pull in the company name field from the related customers table. And essentially, I'm denormalizing the results, similar to performing a join query. I'm also pulling data back from the child table, order details. And here this syntax says I want to call this other field order details. Now, I talked about anonymous typing earlier. I've defined a new type here in the select clause. And now, as I iterate over the results of the query, I'm able to look at order ID, order date, and company name here at the top level. And then for each row returned by the query, I'm able to look at order details and look at fields from the order details table and related tables. So when I execute this query, I'm able to see data from various related tables in the format that I've requested. I'm no longer constrained by the filtering criteria just inside of the data set. With the power of LINK, I'm able to do much more complex things. Back to our slide deck. Link to Dataset is included with Visual Studio 2008 and .NET 3.5. As we've seen, it's the quickest way to use LINK to query data structures that you're already familiar with from .NET 2.0. You can use query capabilities that were unavailable using a dataset in .NET 2.0. You can return the results as data rows or as anonymous types. The main limitation here is that we're doing all client-side processing. The other limitation is that you're responsible for managing the connection to your database. You had to add all of the code to retrieve the data from your database initially, and if you want to submit changes back to your database, you have to manually call the table adapters in the appropriate order. Take a closer look at Link to SQL, which addresses many of those limitations. So what is Link to SQL? Link to SQL is the LINK implementation specifically targeting the Microsoft SQL Server family of databases. It's a rapid application development technology that allows you to take the schema from your SQL Server database, map it to schema within your application model. You map classes to tables, properties to columns. You're able to build queries using LINK. Link to SQL then translates those queries into T-SQL queries for SQL Server, and the results are returned as a series of objects as specified in the LINK query. Link to SQL also supports tracking and submitting changes, so if you modify the results of the query, you don't have to manually figure out how to submit the changes. You don't have to specify your updating logic in your code and remember to send updates top-down for inserts, bottom-up for deletes, etc. Link to SQL takes care of all of those things. So let's do a quick demonstration using Link to SQL in C#. And I'll set the startup project. And we will go into our C# code for link to SQL.
Excuse me, David. We're still seeing the demo slide.
Thank you.
Okay.
I thought there might have been,
There you go.
I thought I'd clicked it. I tried it again, and I thought I had it. Thank you very much, Colleen. All right, here we're going to take a look at link to SQL. And when I create a link to SQL project, I'm able to create an object model by dragging tables from Server Explorer onto this designer. The designer picks up on the relationship between the tables because it knows all about SQL Server. And based on that schema information, the link to SQL designer creates classes based on those tables. It also creates a context class which represents the connection to the database. So this is now my starting point for executing link to SQL queries. Let's take a look at a very basic link to SQL query, very similar to the query we just executed using the data set. And here I'm looking at orders. Again, orders from Argentina for a particular employee. I'm able to create a projection based on this, specify an order by clause, and iterate through the results. Very straightforward, very basic. And now link to SQL is going to take this query and translate it into something that SQL Server is able to understand. Because the query is sent to SQL Server with these filters and with these aggregates, etc., all the query processing is handled by SQL Server, and only the results you're interested in are passed back to link to SQL for your processing at the client side. Now I can take this a step further, a step beyond what we did before, and use more of the power of link. Behold the power of link. I'm going to use a link to SQL query with Lambda functions. So we have the same query we had before, but now I've added a new field. I've added an order total field. And what I'm doing here in the query is I'm saying I want an order total field that says, for this particular order, look at the order details and give me a sum of quantity times unit price. We're omitting the discount field for those who know the order details table all too well. And this expression right here is really just an inline function. I'm telling this sum function what it's going to be doing a sum of. Something called OD. I'm going to pass in OD, and I want to return quantity times unit price for OD. And now once I've built this query up, I can add some summary information to the results of the query. So I not only see just the orders and the order details, I'm able to display the order total. And again, the work is being done by SQL Server. This aggregate function is being called from within SQL Server. It's not being processed at the client side. So I run this query, and again, I see just the orders I was interested in. I see order detail information, and I see order summary information. One question that we often hear is, can technologies like link to SQL take advantage of views, stored procedures, stored functions, etc.? And the answer is yes, absolutely. You can use the designers so that you define, for example, that updates are sent via stored procedures, or queries are executed against views or stored functions. They can be executed against stored procedures. However, you're better off working with stored functions, because we talked earlier about the composability of link queries. Stored functions are composable from within SQL Server. You can execute queries against multiple stored functions on the server and pull back just the results you're interested in. Stored procedures on the server side are not composable. In order to do that, you would need to pull down all of the results of the stored procedure and perform your filtering, etc., on the client side. And that's generally not the way you'd like to handle it. So, back to our slide deck. Link to SQL is included with Visual Studio 2008 and .NET 3.5. As we've seen, it helps you build applications very quickly against SQL Server databases. The queries are processed on the server. The mapping designer makes mapping classes to tables very simple, very straightforward. The mapping is actually done through attributes. In terms of limitations for Link to SQL, Link to SQL only supports the SQL Server family of databases. There is no provider model, and for another company to provide similar functionality, they would really have to do the entire stack. So this is not the technology that we expect developers to be able to work with if they're going to work with multiple types of databases. For example, SQL Server, not just SQL Server, but Oracle, MySQL, DB2, etc. Link to SQL also supports only a limited number of mapping scenarios. Classes must map directly to tables. You cannot map a class across multiple tables. So this technology is perfect if you're in charge of both your application model and your database schema. Link to entities. Get a lot of questions about link to entities and how link to entities differs from link to SQL. Link to entities is the link implementation of the entity data model. The entity data model is another way to define your application model and then map the application model to your database's schema. Now the entity data model, link to entities, and the entity framework, which we'll be discussing shortly, are all designed to work with enterprise-grade mapping scenarios and enterprise scenarios from the ground up. For example, the scenario we talked about before, we were trying to map a single class across multiple tables. That's supported using link to entities and the entity framework. Similarly, you can handle very different inheritance hierarchy mappings using link to entities and the entity framework. Another common mapping scenario that is supported via the entity framework and link to entities is a many-to-many relationship. For example, in the sample pubs database, you have authors and titles. In the database, you'll see that there is a table called title authors. Its sole job is to link authors to titles and back. With a technology like link to entities, that link table does not actually reside within your application model. The sophisticated mapping features of the entity data model allow you to directly map the relationship between titles and authors without having to put that relationship information, without having to put that link table information into your object model. All of that is handled at the mapping layer and then handled automatically by link to entities and the entity framework. So link to SQL and link to entities. What are the differences between the technologies? Link to SQL is going to ship with Visual Studio 2008 and .NET 3.5. Link to entities ships a little later. It's going to ship with SQL Server 2008 as an update to .NET 3.5. Link to SQL has an emphasis on rapid application development. It's very lightweight in a lot of scenarios because it does not offer a provider model or support complex mapping. Whereas link to entities offers a provider model so that third-party databases and provider writers are able to plug in, which allows you to work with link to entities with various data sources. Link to entities also supports much more complex and enterprise-level mapping scenarios. Link to entities is also a very key part of the long-term Microsoft data platform. We're already working with many BI technologies within the Microsoft company, and we're working with those teams so that we can leverage a lot of the functionality in the entity framework from within future Microsoft products. Finally, Link to Entities is just one layer of the overall ADO.NET entity framework, which we'll be talking about more shortly. So let's take a quick look at a demo using Link to Entities and Visual Basic. So we'll move over to our Visual Basic code and set that as the startup project. Now with Link to Entities, we can execute that same query we saw with Link to SQL, pulling back order information and data from related tables, such as company name from customers. And we can include our Lambda expression, here shown using Visual Basic, where we say function OD, and then provide that inline function. Processing the results of the query is done the exact same way we did before with Link to SQL. The major difference here is that now once we've built this with Link to Entities, if there's a change to the database schema, all I need to do is make a change to the mapping information defined here in the entity data model. This information is expressed in terms of XML files rather than in terms of attributes on classes. So that if a DBA, I don't want to say evil or devious, although some developers may think that way, if you've built your proof of concept application and you have a particular database schema in mind, something that's very basic, that maps very well to your application model, if you've defined your application that way, built it, and then built that proof of concept application, and the database administrator looks at your schema, laughs maniacally and says, no, the data isn't going to reside in one table. I'm going to split it across 4 tables. I'm going to really normalize this data. All you need to do is to come back to the mapping designer and update the mapping information to reflect the changes to your database schema. Generate new XML files based on those new mappings. Replace the existing XML files with the new ones, and your application will continue to run. You do not even need to recompile your application. You don't need to redeploy it. All you need to do is change the XML files that describe the mapping from your application model to your database schema. If you move from SQL Server to another database or another database to SQL Server, either way, you're again able to take advantage of all this functionality in the entity framework. Change your connection string to point to the appropriate database. Supply updated mapping files. And again, your application continues to function as it did before, and now you'd be working with an entirely different database. Those are the types of enterprise-level scenarios we're looking to make sure that we handle via Link to Entities and the entity framework. Actually, let me go back to that query. Just make sure that everybody gets a chance to see it run. No smoke and mirrors. Link to Entities, same query, same results. But now it begs the question, how did that query get executed? With Link to SQL is built specifically for SQL Server, and it processed the link query, translated it into something that SQL Server could handle. How does that work via Link to Entities? The first step is that the compiler converts the code into a link expression tree. The Link to Entities technology then converts that link expression tree into a different kind of tree called a DB command tree based on the mapping information that's been provided. That command tree is now expressed in terms of the database schema based on the mapping files. Link to Entities hands that DB command tree off to the underlying ADO.NET provider. In this case, it was SQL Client. The provider converts that into a DB command. The provider, because it understands the particular database it was designed for, is able to figure out what query to generate for that particular database. The provider needs to understand all the querying capabilities, syntax information, etc., for the particular backend. Link to Entities then executes that command and assembles the query results into the structure specified in the link query. All right, we have a couple questions I'd like to address. Does Link support batch processing? No, Link itself does not support batch processing. However, I believe Link to SQL and Link to Entities, when sending updates to the database, do that within a transaction. So you get similar performance in many cases to batching. And that allows you to roll back or to consider sending the entire set of updates atomically. They either all succeed or all fail. Is Link available in Managed C++? That is a great question, and I don't know the answer off the top of my head. Does Link work with Visual Studio 2005? Very early builds did, but what that was doing was it was updating the compiler and had hooks into Visual Studio 2005. I don't believe that's currently supported in Beta 2 of .NET 3.5 with Link, but that is that's something we'll probably get more requests for, and we'll take a closer look at whether or not we can do that. We want to make sure that we complete all the work we want to do with Link and ship Visual Studio 2008 based on the plans we have right now. But we will take a closer look at whether or not that can be done with Visual Studio 2005. Are Link to Entities and Link to Objects the same? Great question. Link to Objects is, the best way to describe that is to work with Link against any structure in memory. Link to Entities is really a way to describe a link-based query against an entity data model that you've provided using the entity framework. Whereas Link to Objects is, for example, executing the queries we did initially against an array, any kind of structure in memory. All right, last question before we get back to the slide deck. Are there ways to optimize link verbs and actions as you would with stored procedures and queries? There's a lot of functionality available in the mapping files so that you can specify, when I work with this particular entity, I really want you to call this stored procedure instead. And we need that mapping information so that we understand when you want to call a stored procedure or stored function and what the results are going to look like, so that you can essentially treat them the same within the scope of your application and leave what's actually going to get executed as an exercise for the entity framework to figure out based on your mapping files. So I know that's sort of an indirect answer. I would advise you to take a look at the documentation for the entity framework and for mapping and stored procedures specifically. You should be able to find a lot of information there. If not, feel free to ask your question on the forums, and I'll show you a link to our MSDN forums shortly. Getting back to the slide deck, Link to Entities is going to ship in the SQL Server 2008 timeframe, in the first half of calendar year 2008, and this will ship as an update to the .NET 3.5 framework. The key benefits to Link to Entities, beyond the benefits that are already there for Link to SQL, is that Link to Entities offers a provider model for third-party databases. Link to Entities is designed for enterprise-grade data scenarios, so we offer a higher level of data abstraction. and much more complex mapping support. And link to entities is a key part of a long-term Microsoft data platform. A link to entities is just one part, one layer within the ADO.NET Entity Framework. We say the ADO.NET Entity Framework, we're really extending and evolving what we'd already shipped before in previous versions of ADO.NET. In this slide, in the diagram, you see ADO.NET providers and the dataset towards the bottom of that stack. Just as we extended the dataset classes to support links to dataset, we've extended the ADO.NET provider model so that the providers are able to plug in and work with the entity framework. We have a new client provider called Entity Client that sits on top of the provider model. Above that, we have Object Services. And above that, we have Link to Entities. Now, Link to Entities we've already seen a quick demonstration of. The entity framework processes the Link to Entities query and passes it down through these various stacks. It's actually the entity client that interacts with the .NET data provider, which passes the query to the database. To process the results, we take the reader returned by the entity client, and that gets processed by Object Services to turn the results into actual objects rather than just giving you a data reader of information. And all these different layers work together. So when you're working with Link to Entities, you're working with the entire stack. But in certain scenarios, you may want to drill down an additional level or two. So what kind of levels are we talking about? For Link to Entities, we saw that query 4, where we execute a link-based query, and it executes against our database and returns results. What's the sweet spot here for using Link to Entities? Well, it's very handy if you want strongly typed queries and results. Because this query is expressed in C# code, if there's a problem with comparisons of data types, whoops. Sorry about that. If there's a problem with comparing the data types, I get that information at compile time. I'm not performing a check inside of a string that's going to fail only when the query gets executed. The compiler helps us out and does a lot of processing, doing comparisons of data types, making sure the results look like what your code is expecting. You get your results back as objects, whether they be the full entities or projections of those entities, so that when you process the results, you're able to get the benefits of IntelliSense, and you're able to write that code much more quickly and pick up on errors at design time. The queries must be well defined at compile time. Here, it's difficult with Link to Entities to add an additional where clause or add an order by clause or make those kind of dynamic changes to the query after you've built the application. However, if you need that functionality, you can drill down one layer into Object Services, and rather than Link to Entities, you can base your query on a class called Object Query. Here we have Object Query of T, Visual Basic code, where the query itself is expressed in terms of a string. I get an object query defined in terms of the order class, and I'm able to process the results. Now here the query is much more loosely defined at compile time. I don't get all the compile time data type checking because I'm working with a string. However, I still get all the design time benefits of working with strongly typed objects. So if you need more control over the query at runtime in terms of filtering, in terms of sorting, etc., this is a great layer for you to work with. The entity client provider, which we showed a little earlier, is another layer beneath the Object Services layer. Here the query is also defined in terms of Entity SQL. But now I use the existing provider model. I work with a connection class, an entity command class. I execute the entity command and I get back an entity data reader, and I process the results as I would using the existing ADO.NET 2.0 model. I'm able to look at the results on a row-by-row basis, looking at the contents of the various fields. Here the sweet spot is if you want to work with untyped queries and untyped results and process the results as data readers. One huge benefit to working with the entity client is that you don't actually have to define classes for your application model. You can simply provide mapping the files and handle all of this on the fly at runtime. This is really powerful and really helpful for anybody who's trying to define a reporting server, for example, where you want to support really complex queries and allow the user to define them as a string and then display the results. Take a look at working with Entity SQL in Visual Basic. Go through this demonstration very quickly. Actually, let's do this in C#. Just did Visual Basic. Get onto our Entity SQL code. And we'll see that we start with the context class again. We call create query. Say that we're working with orders. Pass in the string that defines our query. Here we're using the include method to say that we don't just want the orders, we want information about order details, products, and customers as well. And we process the results based on the fact that we know we're going to be getting orders back. Here we also do an inline function, an inline lambda function to look for the sum of the order detail information. We see that we can do this at the client side after we've created and processed the results of the parent query. We can do a similar query using the entity client provider. Query defined as a string. Now we follow the existing 2.0 patterns. Create a command, open our connection, execute the query, and pull the results back via a reader. And one very nice feature of the entity client provider is I'm able to define nested results. I'm able to get a value back from the parent reader and know that it is another nested reader and process the results of that nested reader and move on. Run the code, and we're able to see the data returned by object query of T and entity client. For more information on the ADO.NET Entity Framework, please visit our team blog. You can find the download links to take a look at Beta 2, both the runtime and the designer, from the blog. And any questions you have, please go to our MSDN forum and ask questions there. We're going to take a very quick look at a technology called Project Astoria. Many developers may have heard a little bit about Project Astoria. I forgot the quotes on this slide. I apologize. Project Astoria is a very lightweight data access API, and we've designed this to work with lightweight web development technologies like Silverlight and Ajax. Essentially what you're doing is you're taking your object model, your entities, and exposing them as a service on the web. Once you've done that from the actual query technology, your code in Silverlight and Ajax, all you need to do is reference the particular service. And that's what we see here in this URI. The first part is the server itself, and then the name of the service. Once you've done that, the rest of your query can still be expressed in that URI. Here we're saying we want the orders for the particular customer whose key value is ALFKI. It's very lightweight. The results are returned in very web-friendly formats, XML, JSON, RDF. And we also offer an online service so that if you're looking to host data and make it available through the Project Astoria technology, you can do that through our online service. We shipped a CTP for Project Astoria as part of Entity Framework Beta 1, or it was designed to work with Beta 1 of the Entity Framework. It's a very early prototype of the technology. We get the basic scenarios down. Right now, Project Astoria is in the process of being productized. So we're looking at it not just as an incubation technology, but as an actual product now. And as a result, there's going to be a slight delay between the release of Entity Framework Beta 2 and then subsequent CTP of Project Astoria. We're in the process of looking at exactly what features and scenarios we believe we need Project Astoria to support in order to be considered a full-fledged product. We don't have a timeline yet for this work. So please, if you're looking for updates, please keep checking on our MSDN blog for the Astoria team. We're going to take a look at some of the queries and the results you can get working with Project Astoria. I already have an application running on the server side. So imagine that this code here within Internet Explorer is similar to the code you're running within Silverlight or within Ajax. All you need to do within your code is reference the particular service, and now in this window I see the schema that's available to me. So if I want to get all customers back, I just change the URI, and now I see the results. If I want to see a particular customer, I can supply the key value in a filter that's similar to an XPath expression. Or I can say something more dynamic like country equals Brazil. I can see I just get the customers back from Brazil, and I can drill down further. Say I just want the orders for those customers, and I get the results back. As I mentioned before, we support various formats like JSON and RDF, and we see the different formats returned here. Astoria is designed to work with technologies like Windows Communication Foundation classes. It doesn't just work with web services. It's designed to be very lightweight, and again, we are taking a look at what scenarios we think it needs to support before we ship the initial release of it. If you have feedback, strongly recommend that you go to the website and send us that feedback. In fact, for more information on Project Astoria, go to astoria.mslivelabs.com. You can find white papers, downloads, forums, blogs, information about our online hosting service there. We really think this is an exciting technology. We really want your feedback so that we know what this needs to do. That's it in terms of our demos. I want to include some information about SQL Server 2008 data types. In SQL Server 2008, we have new date and time data types so that you can get separate data for date and time. We have time zone aware data types. We have new data types for file stream and spatial data types. And you're able to pass parameters into stored procedure that pass in entire data tables or data readers. We've enhanced both our managed code stack and our native code stack to work with these new data types. So for .NET developers, you'll see that systemdata.sql client has been enhanced. We work with the new .NET data type for date-time offset for the dates with time zone information. For pure time information, you can use the time span data type. and you can see the new data types listed in the SQL DB type enum. We have not abandoned our native developers. As we did with SQL Server 2005, we've put out a new ODBC driver, an OLADB provider, and the representations of the new data types are defined in SQL and CLI.h. Summary information. LINQ is a revolution for developers. You can now query objects in memory using SQL-like syntax. You can also work with LINQ to work with various data access technologies like LINQ to Dataset, LINQ to SQL, and LINQ to Entities. LINQ to Entities is not the entire ADO.NET Entity Framework. It's more than just LINQ to Entities. We have a text-based query language, and that allows you to work with either strongly typed results or reader-based results. The Entity Framework also supports enterprise-grade data scenarios for advanced mapping schemas and a provider model to work with third-party databases. The Entity Framework, we get this question a lot, is available as in the SQL Server 2008 timeframe as an upgrade to the .NET Framework. We have one question before I hand off the question and answer slides. How do we use transactions with entities? The Entity Framework is transaction aware. The simplest way to work with entities and transactions is to use the system.transaction namespace. That's it. You don't have to do anything else. Work with the transaction scope object. The work done via the Entity Framework is automatically enlisted in the system transaction. All right. Colleen.
Okay, thanks, David.
Thank you.
Yeah, well, everyone seems to be pretty adept at submitting your questions, but definitely this is the time to go ahead and submit some more if you have any. And also, I'll want to let everyone know that for upcoming and previously live webcasts, please visit Microsoft.com/webcasts. And also, if you have any content ideas, definitely let us know. You can follow the fourth bullet point and submit those to us. And with that, I am going to pull up a survey slide. Definitely please fill this out before you leave today so you can let David know how you enjoyed the session. If you could take a moment and follow the links provided to complete the evaluation. Also, if you'd like a copy of today's presentation, you can go to, you may print to PDF by going to the File menu in the upper navigation bar. And with that, I'll turn it back to David to address any remaining questions and for final comments.
All right. Thank you very much, Colleen. We do have a couple questions coming in. Is there a way to order updates when working with the Entity Framework? When you call the Submit Changes method that's on the context class, the Entity Framework is already aware of all of the changes that have been made to the entities. And the object context has been tracking those changes. So now the Entity Framework looks at those changes effectively as a graph and figures out the appropriate ordering. I know there are events on the class, and there may be a way to have more fine-grained control over the ordering of the updates, but we've designed the logic to work with complex object graphs. For example, the employees table in the sample Northwind database is a self-referencing table. You have managers, employees, etc., all in the same table. Obviously, if you're going to submit a series of new employees, you have to do that in a top-down fashion. If you're going to delete a series of employees, you'd likely want to do that in a bottom-up fashion. The object context and the object services support that are part of the Entity Framework look at that object graph, order the updates in the appropriate fashion, and send them to your database. LINQ to SQL, I'm not as familiar with how that works. I'm assuming it works in a very similar way. What was the first question there? Yeah. When will LINQ to Objects be made available? LINQ to Objects is part of Visual Studio 2008 and .NET 3.5. That is the base functionality that other technologies like LINQ to Dataset, LINQ to SQL, LINQ to XML, LINQ to Entities all rely on. And that is part of the core of .NET 3.5. In fact, one thing I neglected to mention that a lot of developers are very interested in is that there is an iQueryable interface that's defined as part of the core link functionality. And any collection that implements iQueryable of T is literally saying to link, hey, just give me the link expression in the form of a tree and don't try to do the processing. Let me handle turning this tree into something that I can execute, and I will give you the results based on the definition of this tree. And that's what allows a technology like Link to SQL to take the link expression and convert it into T-SQL. It's that same functionality that allows Link to entities to say, I'm going to turn this tree into another tree that's defined in terms of the database schema and hand that tree off to an ADO.NET provider to generate a query against any particular backend and then process the results. So if you're interested in Link in general and you want to provide your own Link implementation for your collection, take a closer look at iQueryable of T. Because for very large structures, you may not want to do all the processing using the link to objects functionality that's already built into the IEnumerable classes. If you want to take ownership of that query against your collection, and it's not a trivial task by any means, but if you want to take ownership of that, take a closer look at the iQueryable of T interface. Well, I wanted to thank you very much for attending the webcast and for all of your questions and feedback. Please fill out the survey as Colleen requested. Colleen, thank you very much for your help. Anthony, you cannot hear him here. Has been invaluable in getting all of this set up in terms of making sure that we have a strong session and helping to make sure that we get the questions addressed. So thank you, Anthony. Thank you very much, and please download and use Beta 2 of the Entity Framework and the rest of the features available in .NET 3.5.
Great. Thanks so much, David. Once again, I'd like to remind everyone to please take a moment to fill out the survey before you exit today. And I'd like to extend a special thanks to David for his presentation and also to Anthony for handling questions. And ladies and gentlemen, that does conclude today's live meeting. Thank you all for joining us. You may now disconnect from the audio portion of this event.